Okay, so what we're going to look at in this little video is a couple quick examples for how to graph to solve systems of equations. So we're looking at solving systems of equations by graphing in this particular video. So the first one we're going to do here, we're actually going to do two right here right quick. The first one we're going to do is number 2. We're going to do number 2 because it has fractions. So I want to make sure we're clear on how to do the fraction ones. Remember, the easiest way to graph is to graph when things are in slope-intercept form. So remember, a slope-intercept form is y equals mx plus b. So b is your y-intercept. So I'm going to graph my first equation here in purple. So what's my y-intercept? Well, that's the number that's being added or subtracted. So that's going to be 1. So I have a positive 1. My slope is negative 5/3, which means I'm going to go down 5 and write 3. Because negative 5/3, that's negative 5 over positive 3, or it could be positive 5 over negative 3, in which case I would go up 5 and right 3, or excuse me, left 3. And then you want to draw your straight line. Mr. Rankin probably has rulers, or you might have rulers. You could use your passbook, whatever, to get your straight line. You saw I used a notebook. So there's my first line. Second equation, we have y equals negative 1/3 x minus 3. So my y-intercept is negative 3 this time. I'm doing this one in green. So I've got negative 3. And my slope is negative 1. So in this case, it's negative 1/3, which means I could go down 1 and write 3. Or I could go up 1 and left 3. And then you want to connect those. So remember, when we graph these, we're looking for where they intersect. So it looks like my point of intersection is right here, because that has both green and purple on that dot. And so that is the ordered pair, positive 3, negative 4. And you can check it the same way. Negative 5/3 times 3 is negative 5. Negative 5 plus 1 is negative 4. Negative 1/3 times 3 is negative 1. Negative 1 minus 3 is negative 4. It's good. The other one I want to look at on this particular page is number 3. And the reason I want to look at it is because the first equation we're going to do in purple. What's our y-intercept? Well, our y-intercept is 1. What's our slope? Well, our slope is negative 1. So that means negative 1 over 1. So we're going to go down and right. Or you could go up and left. Put as many dots on there as you want, and then connect your dots. Okay? Then the second one is the reason I chose this particular one to graph. It says x equals positive 3. X equals positive 3. If it's x equals, that means that this line is vertical. So I go to the x-axis, and I draw a line at 3, and it's a vertical line, which means it's going up and down. Where do they intersect? They intersect at 3, negative 2. Now, if it had been y equals 3, then that would have been a horizontal line. If it would have said y equals 3, that would have been a horizontal line, and it would have been through here. So then our answer would have been negative 2, 3. So that would have been horizontal. The other one I want to look at on this particular graph is number 12. Number 11 and 12 are not in slope-intercept form, so we need to put them in slope-intercept form, which means we need to solve for y equals mx plus b. Now you can also graph it using intercepts, but that doesn't always work out nicely. So I'm going to start and I'm going to do my first one in purple like I have been. So my work for my first one's in purple here. X minus 4y equals negative 4. So negative 4y equals negative x minus 4. Divide everything by negative 4, so y equals 1/4 x plus 1. I went fast, but you can slow down the tape and rewind it. So our y-intercept is at 1, and our slope is 1/4. So that means we're going to go up 1 and right 4. And we're going to go down 1 and left 4. And we're going to connect our dots. Connect the dots, la la la. Connect the dots, la la la. So that's my first equation. Now, if you had wanted to, the other way you could have plotted that point was using intercepts, because it's in standard form. So the first intercept is when x equals 0. So that means that 4y equals negative 4. So y is 1. Hey, we have that. The other one is when y equals 0, which means x is negative 4. Hey, we have that. And then you connect those dots. The second equation is not quite as pretty. Okay, so we have 5x minus 4y equals 12. So if I'm working that out, 5x minus 4y equals 12. Whoops, 12. So I'm going to start by subtracting 5x. So negative 4y equals negative 5x plus 12. And then I'm going to divide everything by negative 4. So y equals 5/4 x minus 3. So my y-intercept is negative 3. And my slope is 5/4, which means I'm going to go up 5 and right 4. And then I want to connect those. The place that they both intersect, the place that there's both purple and green, looks to be the point 4,2. So that's my solution. So those are the two things you need to be able to do in order to solve by graphing. Okay? So thanks for tuning in. Catch you next week.